Hi everybody, this is Algebra 2, Lesson 52. In this lesson we're going to cover chemical mixture problems, type A. Alright, so first question says, a druggist has one solution that's 10% iodine and another that is 50% iodine. How much of each should the druggist use to get 100 milliliters of a mixture that's 20% iodine? So first I'm going to draw a little picture to demonstrate what it is they're talking about. Alright, so we've got one container, and they're pouring some liquid out of this one, and this is our 10% solution. Alright, so then they've got another container, pouring some liquid out of this one, and this is our 50% solution. Alright, those are going to mix together into this container. So those pour in and they mix. And we need this one to be 20%. And the volume of this one is going to be 100 milliliters. Alright, so first thing we need to do is name each of these. So we're going to name this one our pour number, so the amount that we're pouring, and we're going to name this one our dump number. That's the amount that we're dumping. Alright, so we're going to have our pour number, so the amount that we pour in, the amount of the 10%, plus our dump number, the amount of the 50%, equals 100 milliliters. So it's going to equal that, the purple, because that's the two mixed together. Alright, so then we're going to change these percents to a decimal. So 10% would be 0.1, and 50% would be 0.5, okay? And 20% would be 0.2. Alright, so we're going to say 0.1 times our pour number, right here. Pour number right there, 0.1 right there, okay? And our dump number is 0.5. Oops, I need to do my 0.5 first. So 0.5 times the dump number equals 100, and the percentage on the solution of 100 is 0.2. Alright, so I'm going to do 100 times 0.2. That means I just move my decimal 2. That will be 20. So 0.1 for Pn plus 0.5 dn equals 0.2 times 100 would be 20. Alright, now I can't solve because I have two different variables here, so I need another equation to make this only be one variable. So I could say my pour number plus my dump number equals 100, and then subtract my dump number from both sides, kind of like we do with the coin problems, and then we'll have pour number equals 100 minus dn. Alright, so 0.1 times Pn, and we know Pn's value over here is 100 minus dn, so we're going to say times 100 minus dn plus 0.5 dn equals 20. Alright, now we're going to multiply this, distribute that out, so 0.1 times 100 would be 10 minus 0.1 right there times dn plus 0.5 times dn equals 20. Alright, now I've got like terms I can add right here. So I've got positive 0.5 and negative 0.1. So 0.5 minus 0.1. Oops. 0.5 minus 0.1 would be 0.4. So I'm going to have 10 minus 0.4 dn equals 20. Now I got to subtract 10, and I'm going to get negative 0.4 equals 10. Now divide by 0.4. Let's see, 4 times 2 is 8. 4 times 5 is 20. So my dn equals 25. So up here, dn is 25. And now I know that my Poor number is 100 minus dn. So Poor number equals 100 minus 25. So my Pn is going to equal 75. Alright, so the answer to that one is Poor number 75, Dump number is 25. And you could use anything. You could use something other than Pn and Dn. You could be like solution A, solution B. Alright, let's try another one like that. A chemist has a solution that is 10% salt. So I'm going to use this orangey color. And that's 10% salt. And 90% water. And another solution that is only 2% salt. %2 salt. So I've got this one, which is 2%. Okay. And those are mixing together to make, how many milliliters of each should the chemist mix to make 1,400 milliliters of a solution that's 6%? Okay, so this one's got to be 6%. Alright, so we're going to name these. This one's going to be our DN and our PN. And that would convert to 0.1. That would convert to 0.02. And this would be 0.06. Because when you're changing a decimal, a percent to a decimal, you would say 6%. You move your decimal point 2 to the left. So you get 0.06. Alright, so we're going to say our DN plus our PN equals 1,400. We'll go ahead and make our DN equals 1,400 minus our PN. So I just moved that to the other side, changed its sign. Alright, so then we're going to say 0.1 DN. So I'm just multiplying right here. 0.1 times dn plus 0.02, multiplying right there. Pn equals 1,400 times 0.06. There we go. So I'm going to multiply that out. So 1,400 times 0.06. 4 is 24. 0. 6 times 1 is 6, 7, 8. Move my decimal 2 places, 84. So 0.1 dn plus 0.02 pn equals 84. Alright, now I have to substitute this value in every time I see dn. So there's my dn. So I'm going to say 0.1 times 1,400 minus Pn plus 0.02 Pn equals 84. And now I'm going to distribute that. So 0.1 times 1,400. And then I need to move my decimal 1 time, so 140 minus 0.1 Pn, because I distributed here, okay, plus 0.02 PN equals 84. Now I got my like terms I have to put together. I've got negative 0.1 and a positive 0.02. So if I put that there, I'm going to end up with negative 0.08. So 140 minus 0.08 PN equals 84. Now I'm going to subtract 140. Those cancel, and I get negative 0.08 PN equals 140 minus 84. 8 and 4 is 12, so 56. And that's negative. Now divide by negative 0.08. Those cancel, and my PN should equal, let's see, I've got these negatives will cancel, so it'll be a positive 56 divided by 0.08. Move my decimal 1, 2. Move my decimal 2 here. 7 times 8 is 56. Bring up those zeros. 700. So that means my PN is 700 milliliters. And if I already have DN equals 1400 minus 700, my answer is going to be DN equals 700. So they're 700 each. Right? So 700 milliliters on each of those. Alright, I hope that made sense to everybody. It's a lot like the coin problems. Alright, try the practice problem. There's only one. Pause the video, try to work it, and then I'll work it for you. Alright, so practice problem. I'm going to draw my diagram. Now, you guys don't have to draw these diagrams, but I feel like it could be helpful. So first we're going to have, a chemist has one solution that's 25% salt. Ignore the 75% right here. And another solution that is only 5% salt. So this one's 25%. And then we've got another one. That is 5%. How many milliliters of each of the chemists used to make 1,600 milliliters of 15%. So our product here, what we're going to get is 15%, and it's got 1,600 milliliters. Alright, so first thing we're going to do is name these. So our pour number and our dump number. Okay, and we know that our pour number plus our dump number, make sure how that D looks good, equals 1,600. We could go ahead and make this other equation. So our pour number equals 1,600 minus our dump number. Okay, and we're going to change this to 0.25, change this one to 0.05, and change this to 0.15. Alright, so we're going to say 0.25 PN plus 0.05 DN equals 1,600 times 0.15. Alright, so then I need to multiply that out. So 1,600 times 0.15. 5 is 30. 5 times 1 is 5. 6, 7, 8. 0, 0, 6, 1. Add them up. 0, 0, 0. 6 and 8 is 14. 24. Bring my decimal 240. So 0.25 PN plus 0.05 DN equals 240. Then I'm going to fill this value in for my PN, so 0.25 times 1600 minus DN plus 0.05 DN equals 240. Now I'm going to distribute that, so 1600 times 0.25, that'd just be 1/4 of that, should be 400. 6 and 5 is 30, and 1 is 5, 6, 7, 8, and then 0, 0, 2 times 6 is 12, 2 times 1 is 2, 3. The decimal comes over to 400, yep. 400 minus 0.25 DN, I distributed there, 0.25 times DN, plus 0.05 DN equals 240. Now these are like terms, so I've got to put those together. Negative 25, positive 5, I'm going to get 400 equals 0.2 DN, because I said, I'll go down here, 0.25 and 0.05, and I get 0.20, which is the same thing as 0.2. Alright, and that'll be negative 0.2 equals 240. Now we're going to subtract 400. Those cancel, and we get negative 0.2 DN equals 240 minus 400, so we'll have to say 10 minus 4 is 6, 2 minus 2 is 1, 160, negative 160. Now we're going to divide by negative 0.2, and we're going to get DN equals 160 divided by 0.2, and these negatives cancel each other out, so our answer will be positive, go over 1. 8 times 2 is 16. Bring up those zeros, 800. So our dump number is 800 milliliters. And then we know that PN equals 1600 minus 800. So that's going to be 800 as well. Double check that on the answer key, but I'm pretty positive that's right. Yep. So these are just like the coin problems that we've been doing. Make sure that when you write the answer to these, you label it as 800 equals your 25%, and 800 equals your 5%. That way I know which one's which. Okay, so that's what your answer should look like when you put it on your homework. All right, thanks for watching. Bye.